This week, we welcome Peter Smith, the founder and CEO of Edgewise. That's right. He's here to talk about Zero Trust and show us a little product demo on how it works. In the security news, a new WordPress flaw even lets unauthenticated remote attackers hack into websites. Tesla has allegedly run a smear campaign against a whistleblower. Facebook, Instagram, and Google have suffered outages all in the same time frame. And we'll have some conspiracy theories about that. What to do with sexy selfies, search warrants, and tax files and what they have in common. In the final segment, we'll air a pre-recorded interview with Karsten Wilhelms, the co-founder and CEO at VMware, discussing malware sandboxing. All that and more on this episode of Paul's Security Weekly. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Organizations' internal networks are overly permissive and can't distinguish trusted from untrusted applications. Attackers abuse this condition to move laterally through networks, bypassing address-based controls to spread malware. Edgewise abstracts security policies away from traditional network controls that rely on IP addresses, ports, and protocols, and instead ties controls directly to applications. Edgewise allows organizations to analyze the network attack surface and segment workloads based on the software and how it's communicating. Edgewise monitors applications and protects data paths using Zero Trust segmentation. Visit edgewise.net/Security Weekly to get your free month of visibility. Some restrictions apply. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/Security Weekly for an unlimited data trial and gain uncompromising visibility today.
And welcome to the show. But first, let me introduce you to a man who has the bladder of a 6-year-old girl. Normally I'd say in a jar in his basement, but no, he's peed like 3 times since I've been here. Paul Asadorian.
Welcome to this edition of Paul's Security Weekly. This is episode 597, recorded on March 14th, 2019. We're here in G-Unit Studios in Rhode Island, and Larry's pointing the fact my bladder is really small, apparently. But Larry's here in studio.
Yes, and one thing other that I just noticed too, at looking at you in the camera, we better be careful about what memes we put in Slack because they reflect off your glasses.
Yes. Yes.
Or not.
Or not. I'll be removing my glasses.
Yes, it's good to be back here in the studio after a couple weeks hiatus and so forth.
Hiatus and hiatus.
Hiatus and hiatus.
Hiatus and hiatus. That'd make a good episode title, actually. Yes. On the lines remotely, Mr. Lee Neely is here. Lee, welcome.
Good to be here from the Boise area. We're enjoying a little sunshine, but it's still about 40 degrees.
Nice.
And,
nice.
Nice shirt.
Oh, yeah, we saw Lee at RSA, and we gave him his
nice
quarter zip. We call those.
Yes.
Very nice. Looking
Awesome
sharp.
shirt. Thank you very much.
You're welcome. Thank you. Mr. Jeff, Jeff, you look like you're on a green screen.
Isn't this cool?
Yeah. Like
Skype has a new blur the background feature.
Oh.
What the hell?
Yeah.
About the only usable improvement they've ever made to Skype.
Right?
Well, that and the emoticons, but we can only see those in the chat.
Like I said, the only usable.
The only useful feature. Yeah.
So you like it? Should I keep it?
It looks like you could be anywhere, except it blurred your hands when you raised them up. It's pretty awesome.
Uh-oh, did it?
Looks like, yeah. Like if you back them up a little bit, it like went into the blur.
Whoa.
Dude, it's kind of
Okay, we're not too distracted.
yeah, it's very distracting.
I've never seen anybody take that much acid before.
Right?
Hey, it was good to see everyone out in San Francisco last week. I actually got a chance to meet Lee in person. That was fun.
Oh, you guys had never met in person?
Yeah, we'd never met in person.
Well, on to the announcements, and we'll dive right into the show. We've got a lot of ground to cover. This week, we have just released our 2019 Security Weekly 25 Index Survey. So basically what that is, Matt Alderman selected 25 public security companies, and we're doing all kinds of segments on tracking these 25 companies. Part of our fun that we're having with the Security Weekly 25 is if you go to securityweekly.com, click the survey link. We want to know from you which of these 25 vendors that you're using and get a little information about how you might be using some of these companies, of course, all anonymously, and this will be summarized and presented back to the responders in a private webcast. The Security Weekly guest request form is live. That's right. For the first time ever, now you are able to suggest a guest. If you're a listener of the show, you can go to securityweekly.com/guests, fill out the form, and we will do our best to bring that guest on the show. Peter Smith is here with us. He's the founder and CEO at Edgewise. He went to Harvard Business School, right? Is that right? Is that right, Peter?
Yeah, that's where I started my career.
Nice. And you were involved with NAC Systems before founding a couple different companies, and we'll talk about your background. Peter, welcome to the show.
Thanks.
So, Peter, how did you get your start in information security?
Let's see. I originally started going to music school and realized that probably wasn't it for me. So I got an internship in a data center. The second I set foot in, I knew that was my future. So I then went on to Harvard and was their infrastructure and security architect for quite some time. Then on to Endeca Technologies, where they invented faceted search, which we take for granted, but it was pretty amazing technology back then.
That's awesome.
And yeah, as you mentioned, started a distributed storage company and then on to Edgewise.
That's great. So where did the idea for Edgewise come about?
Yeah, it was actually at Harvard Business School. So back then we were all focused on NAC, right? The goal of NAC being to make the network secure. And at some point I realized that that's sort of a futile goal.
Right.
And
so Peter,
I'm
sorry, in what time frame were you looking at NAC in the university space?
In the mid 90s to early 90s.
Okay.
And,
okay. You were actually ahead of the curve.
Oh,
Well,
yeah, definitely.
that was on the beginning of the bell curve there.
Yeah, sure.
So I built this NAC solution at Harvard and ultimately replaced it with Cisco Clean Access.
Yep.
I later met Bob Glykoff, who was the CTO of InQtel. And I found out he was the original author of Cisco Clean Access that I replaced my original NAC solution with.
It's funny how things come full circle like that. I started in university in 2001. And of course, very shortly thereafter, worms started running around all of the universities, and we were like, "Oh my God, we need a NAC solution." And of course, I think even still today, it's very difficult to implement NAC effectively. I mean, back then, I think it was difficult to implement regardless. And now, to be completely effective with NAC, I still think it's challenging.
It is. It's pretty challenging, and I think it strikes at the core of sort of zero trust philosophy.
Yeah.
Not to launch headlong into that, but
No,
really,
go for it.
I mean, NAC is to make the network secure, which is really a difficult to achieve goal. And zero trust is to say, can we operate in an insecure network? Can we confidently deliver services in spite of the fact that the network is not secure and never will be secure?
Right. And so that's a logical progression of going into the zero trust that we've learned about from Edgewise and Harry and others, right? Coming from the NAC space to deal with some of those challenges and issues.
Yep. Yeah, totally. Especially now with the cloud. Frankly, you don't own the network. You don't own AWS. You don't own Azure. You don't own any of that. And you give up a certain amount of control, and you still need to be able to operate confidently in it and deliver your services.
Yeah, I wholeheartedly agree with that. One of the themes that I actually have been seeing at RSA and just in general is that now focus on the user and the data or application, right? The middle layers are just there as a transport now, and there's some level of security in those middle layers, but I think as an industry, we're really pushing out towards the user and the app, and of course the data as well. But the protection has to be in the app as an example, because your app now is just going to run anywhere and everywhere. Like the infrastructure, it used to be you racked a server in the data center back in the day, you know, and did that whole dance. Now it's not even so much that your presence of a server is in the cloud, is that you're just putting your app up in the cloud. And so something like Edgewise and Zero Trust is something we desperately need because we still need to protect the app.
Couldn't agree more.
So Peter, you have a demo to see how it works, and I think I think it's great timing. You know, Harry's been on the shows talking about it. I think certainly myself and our listeners are like, now I want to see it, and here's your opportunity to showcase it. So it's awesome.
I'd be happy to. And you know, before I jump into that, I think it's worth noting that Zero Trust, there's really sort of two sides to it. There's protecting access to an application, and then protecting the application that people are trying to access, right? And we typically break that into two categories. It's sort of the Google BeyondCorp model, and then the Kinderwaag model that came out of Forrester. And really, we focus on the Kinderwaag model, what most people would refer to as micro-segmentation. We do it with a twist, two twists actually. One is machine learning based automation, and it's really about automating the operational tasks associated with micro-segmentation. And the second one is using identity to verify communications in the data center. And it's identity of software and devices and other things, not the classic notion of identity, which is aligned with user.
Right.
Yeah, I'd love to show it to you.
Awesome. We'll give you a moment to share out your screen.
Paul gets that a lot. He's kind of a sexy guy. I'd love to show it to you.
Yeah, you know. Comes with the territory, apparently.
So you guys have all deployed firewalls in front of a data center.
Yep.
Unfortunately, yes.
Just last week, in fact.
What did you do to accomplish that?
A lot of ripping and replacing stuff in the server closet, and taking down the network, and installing hardware and software, and writing rules. Yeah.
So writing rules, that probably took quite a bit of time, right?
No.
Actually,
no, because I would put IP any
right.
deny.
Right?
No,
right? Yeah.
Kidding. No, because that doesn't work. Right.
And any Zero Trust implementation. Then.
Yes.
Right.
Yeah.
Well, and one rule any allow is also makes everything work.
Right.
But I had to balance multiple WAN connections, and it turns out I had to write a lot more policies than I thought I would have. But if I didn't have that, typically my policies would be pretty basic, right? And I would just deny everything that was trying to come in, really at all. In this case, but then you start making exceptions, and things get ugly.
Oh,
right,
yes, they do.
Exactly. And a lot of the people that do this on a day-to-day basis, they have no choice but to make risk-based decisions, right?
Yep.
I put a firewall in front of a data center. I collect a couple months worth of logs. I throw it into Excel, pivot table, and ultimately I see, why is there an SSH connection coming from the finance network? And I have to make a decision. Do I let it go or do I drop it?
Yep.
But all of a sudden with micro-segmentation, the networking team needs application level knowledge, very specific low level application knowledge to figure out which of these systems do I group together. And that is fundamentally the problem we're trying to solve. So let me jump in and show you how easy it can be to micro-segment and share with you what the ultimate results are. So we have this concept called collections. Collections are groupings of software. It's really neither here nor there. It's just to say that we will group together software and hosts. We've automatically grouped together Active Directory servers. That's one of the things our machine learning does, is it identifies communities of systems that should be grouped together in microsegments. So what we're going to do is figure out how quickly we can build all of the exception policies that need to allow access to Active Directory. So it's really simple, actually. We just hop in here, and I move all of these tiny little video windows out of my click path. So we're in the Active Directory hosts, and we want to build some exceptions. We literally just ask the question, what are the services that should be able to be accessed from the outside? We select them, we build destination, and we call it services. And I'll just call it services Peter 22. Now that we have the list of services that need to be able to accept connections from the outside, we're going to select that as our target, and we're going to say, show me the groupings of applications. We select those, we scan the list, and it's worth noting all of the identities of all of this software. It's already scanned through 52 anti-malware scanners to get rid of anything that is known to be malicious. So we're really just scanning the list for multi-use software outliers like that. So we get rid of Telnet. And we say source is clients. Now all we need to do at that point is add the client object, approve it. And again, my little video windows are in the way. And apply that policy. Last step, turn on enforcement. And really, it's as simple as changing our target to the underlying host collection, which is our segment, and saying, shields up, and you can talk to yourself, AD servers.
Talk amongst yourselves.
Talk amongst yourselves.
It's like
so
butter.
I click apply, and I have just fully micro-segmented Active Directory. And it gets a little interesting here. Check this out. If I come over here and I select my services, and I expand it out, and I say LSAS, this is a map of all communications to LSAS that are allowed. You can see there's one block connection. If I expand that up, oh, it's Telnet, as you would expect. If I expand this out, this is all the software that's allowed to talk to LSAS. And what we're doing is we're actually verifying the identity of the communicating software, device, container, and host. So if I say that LSAS can receive a connection from LSAS, what I'm actually saying is that the software verified and identified by these cryptographic properties is allowed to talk to the software identified and verified by these cryptographic properties, including PE headers, signing certificates, and all of that. So we will not allow any software to communicate that is not first verified based on its cryptographic identity. And all I needed to do to fully segment and fully protect my Active Directory was maybe, what was that, 15 clicks? And that was all driven by a machine learning model that maps the topology of your environment, does Bayesian analysis of communication patterns, and reduces it to a small set of patterns of identified software to make sure it's only that legitimate set of communications. Pretty cool, right?
That's really awesome. So, Peter, to gain a map of the internal network, I'm assuming that there's some kind of system on the internal network. It probably doesn't need a span port, right? It's just listening to broadcast traffic and observing things to make that map, right?
So we need software identity. My position is that you cannot achieve automated and trusted policy definition by looking at network traffic alone. The network traffic alone is just address port protocol, maybe a bit of payload information to identify layer 7 protocol. To make decisions about what should be able to communicate, you need to know the software that is communicating. And you can't figure out what the software is by looking at network traffic. It's just not possible. You couldn't differentiate a connection from a Java application versus Telnet or MySQL admin command that's trying to talk to a database by looking at packets. And so we really need to collect these properties. And to answer your question, it's actually a dynamically loadable kernel module that allows us to do all of this and protect with less than 5 microseconds of latency. It's really just a phenomenal invention. And we don't do it with looking at any network traffic. We're looking at software identity, and that's it.
Well, yeah, because of course network traffic can be encrypted, and while you may have port communications to a specific port, you really don't know what that is unless you can inspect it. And if it's encrypted, you can inspect it, right?
Exactly. Exactly. You hit the nail on the head. So why don't I show you what the difference is between a address-based control and a software identity-based control. And we refer to this as zero trust identity, the cryptographic identity of communicating software that's verified. So let me show you the difference between a next-gen firewall that's doing deep packet inspection to look at protocols versus verifying communicating identities at the software level.
Awesome.
Sound good?
Yes, that's awesome.
Okay, let me stop sharing my screen for 1 second and I'll be back.
I have a question for Larry while this is happening.
Sure. Yes.
How would you attack this?
Oh, that's a great
I
question.
love that.
It's a great question. I wasn't quite there in my thought process yet either, Larry, so don't feel bad.
And specifically thinking about one of those, protecting Active Directory with LSASS with signed binaries and all of that type of thing. Yeah, this very much turns into the case of having to live off the land and using those signed binaries by Microsoft and so forth and so on, which is becoming harder and harder to do in some environments.
Yeah, well, it's interesting, Larry. Like you're kind of like my first thought as well. I gain some kind of foothold into a system that's trusted, but how do you do that if it's not going to trust you like it trusts the other system? So
Right.
But if I'm understanding, the trust isn't based on the system anymore. It's based on applications talking to applications, right?
Correct. But I guess I need to access an application to gain access to a system, right?
Well, you didn't used to, but that's probably true these days.
Right. There's some process that I have to access that listens on a port or whatever, right?
Yep, absolutely.
Yeah, I think the trick is multi-use versus single-use software, right? So the cryptographic identity of software is an identifier that basically says there's a set of capabilities the software can do, and it's basically identified by this string here. And your software isn't going to magically learn how to compromise Heartbleed. Like your Java application doesn't suddenly learn how to compromise Heartbleed. So the cryptographic identity of that Java application describes a very bounded set of capabilities that jar is able to accomplish. That's why you need to focus on multi-use software and really clamp down access for multi-use software. So a good example of that is Telnet. Let's say, for instance, if I were only looking at signing authority in the PE headers of a Windows binary, and I want to compromise something that accesses a database, an MS SQL database, maybe I rip out the MS SQL database and I replace it with a Telnet binary because they're both signed by Microsoft, and then I use Telnet as a proxy into something that is bad. So if you were just using signing, then sure, you could do that and accomplish the hack, which is why it needs to be this very composite view of attributes of the binary. It's not just signing. That is to determine whether something comes from a trusted source. You also need to figure out how similar it is to the thing that had policy before it, so that I can't just replace a binary and it says, oh yeah, sure, you get all of the access that previous binary had. So it's a really interesting problem that I'd love to chat more about.
It's interesting, Peter. I like what helps me understand is if I relate it to a user, and in the scenario you just described, right? I can steal a user's credential and try and pretend to be that user. But if you have something that's analyzing user behavior, you may very quickly not trust those credentials anymore. You're doing the same thing, but for applications and processes.
Exactly. In fact, a really good way to think about what we do. Think about MFA. So you want to log into something, you need some MFA code, you pull out Google Authenticator, you look up the code, you put it in. Well, what do you do for servers? Servers don't have a phone they can go look up an MFA key for. They can't get text messages, they don't have an RSA key fob, right? So how do you do MFA between software running on servers that are communicating? That's effectively what we're doing. We're just using the cryptographic identity of the software itself, the container it's running in, the user or service account that's executing it, and the underlying host itself to do the multi-factor authentication for server-to-server communications.
Yep. Makes sense.
So let me show you how powerful this is. So here's the scenario. And please, if you've got any questions or want to poke holes in this, have at it. I would love the discussion. So here's the scenario. We've got an attacker who's taken advantage of all of this extraneous network access that your large network segments have allowed. They've moved laterally. They find themselves on an application server. The application server, as you can see on the screen, is LinApp user 01. So me as an attacker, I've got a decision I need to make. What do? Do I scan your network and try to figure out what the next logical hop is? Or do I try to piggyback over existing network connectivity? So as you can see on the screen, I want to first, because I know you're sophisticated. I know you're going to detect my scanning. So if I can live off the land here and try to piggyback through existing connectivity, I'll have a much better shot at pulling this off without getting caught. So the first thing I do, I'm going to use NetStat. I'm going to just list connections in and out of the box. So when I do that, the first thing I see is a connection to a remote MySQL database. So what do I need to know? What I need to know is what version of that database am I looking at? Is there an available exploit that I could use? How am I going to move laterally or compromise this database? So again, Telnet, it is a perfect tool for this. If I want to live off the land, I take Telnet, I point it at the listening port of MySQL, port 3306, and I just make a basic TCP connection to it. Because what I know is that I'm going to get a handshake back from the database. The handshake is negotiating the version of the wire protocol that we should use to communicate. Now, it's worth noting that everything I'm doing right now, there's a leading next-gen firewall sitting in the middle. It's got security profiles set to strict enforcement. Definitions are latest updated, and they use application identity-based layer 7 protocol validation. So when it saw this connection, it said, hey, first 4,096 bytes of the network connection, that matches the fingerprint for MySQL, looks good, come on through. Well, it wasn't good, it was Telnet. It just couldn't differentiate the business application. So now I know the version of the database. What do I do with that? I mean, all roads lead to Google, right? I go to Google, I type in MySQL 5510 ODay remote code, fourth one in the list. From 2012 is MySQL Jackpot. So I'm going to download MySQL Jackpot, and I'm going to point it at this database. And again, this firewall has latest and greatest definitions. So when I point it at the database, it does two things. First, it does the exploit, which is basically a SQL statement that had some, bogus handling of the SQL statement that allowed a plugin basically to be loaded into the database. That happened, firewall saw it, didn't say a peep. When the DLL loaded, it initiated a reverse shell back to the application server. And I was able to slip in the net user administrator command to change the password before the firewall security profile said, hey, that looks like a reverse shell, drop the connection. So I've changed the remote database administrator. The other point is, this is a little bit showy, right? Like I would have just put the change password into the DLL. I loaded a DLL and I'm running it as an administrative user. I could have done anything with that. So I didn't need to use a reverse shell. That was just a little flashy. The last thing I could do is why not more living off the land? Take the MySQL admin command, steal some credentials, point it at the database, and again, list the user's table. From the firewall's perspective, every single one of these things said, hey, looks like it's coming from the app server going to the database server over port 3306. And every single one of these looks like MySQL protocol. Come on through. So that's the problem. Layer 7 protocol is not equal to software. If you want to verify connectivity, you really need to verify the identity of the software. So you want to see how we fix it?
Absolutely.
Yes.
Cool. So we're going to log into Edgewise. And the first thing to note is we're verifying these cryptographic properties on both sides of the network connection before the connection is allowed to make sure it's only the legitimate user's microservice talking to the MySQL database. The way we do that, we say approve, or you could do the same thing that I showed you for Active Directory protection. What I'm showing you now is that it models the impact of this policy decision. When I enforce it, it verifies that that is what's happening. Only the user's microservice is allowed to talk to the database. Everything else, Telnet, MySQL Jackpot, and the MySQL admin command, they are not allowed to talk. So let's go through every of the 3 scenarios. I do Telnet, permission denied. I point the MySQL exploit at it. Sorry, permission denied. I tried to use an admin command like MySQL admin, permission denied. And it's as simple as this. None of those 3 pieces of software were cryptographically the same as the approved software, which was the user's microservice. As a result of that, the database simply will not accept the network connection, full stop. So you can get this level of protection in literally 10 clicks using ML-based automation to drive the process of microsegmenting without having to collect all of that information for firewalls, pivot table, build policies. It's all automatic, and you get that level of protection.
So I have a silly old-timer question. In terms of the old days of firewall rules, is this, are you setting up explicit allows, explicit denies, or is it a hybrid?
Oh, that's a great question. It depends on the mode that you deploy it in. There's a mode where you can say database will only accept approved network paths. If that's the case, then you're basically saying default deny, and then you explicitly allow everything else. But there's also a world where, I'll just show you, it'll be a lot easier. I'm going to go to a database system. I'll select it, view connections, get rid of my sidebar here, and I'm going to look at linuser DB01, and I'm going to go to the MonGod system and show you what's approved. If I say that I will only allow the login service to connect, and I'm going to approve that right now. As a consequence of that, MonGod
We're looking at you,
saying,
not your screen, by the way, in case you're.
Oh, you can't see my screen?
Yeah, sorry.
Oh, I'm
we're
so
looking
sorry.
at you. Not that you're on a.
You were doing a great job describing it, so I felt like I could see it. Yeah.
Well, I appreciate you you stepping in there. So now, can you see it?
Yes.
Yes.
Okay, great.
Now.
So to answer your question about whether it's a hybrid mode or just a strict blocking, if I come in here and say, hey, MonGod, accept only approved paths, and I turn that on, that'll say, unless you're approved, I don't accept your path. So certainly you can do a default deny. But if you want something else, like the LinApp user server, when it tries to talk to MongoD, I only want login service to be able to connect. What you're doing is localizing the default deny to just that server. So I can say, if it's LinApp user talking to MongoD, only login server, nothing else. But MongoD will accept connections from everything else in the environment without doing any verification. So it is a hybrid model. You choose. Do you want to fully protect MonGod, or do you want to do localized protection for specific interactions with the MonGod system?
Okay.
So
I suspected it was hybrid. So thank you.
Yeah. So Peter, in that sense, are you trusting the system or the applications? In other words, when you connected with using Telnet, can you distrust it based on the system that's connecting, or because the Telnet binary is the one that's connecting to the MySQL server, and therefore that's distrusted?
It's a great question. You can do it both ways.
Okay.
So if you want to say, let's say for instance, I came over here and I said my collection is, I'll get rid of this and I'll say application blacklist. I can go into application blacklist and I can add Telnet to the blacklist. And as a result of that, Telnet will not be allowed to communicate anywhere in the environment on any host between any host. You are wiping Telnet from being able to communicate in your environment.
I know a bunch of network admins that would hate that.
Mm-hmm. And that presumes any port as well, right? It's actually looking for the Telnet, whatever
binary.
Telnet, the initial handshake.
It doesn't matter if you change the port, it will still work. It is completely port agnostic, which is super important for things like Active Directory and otherwise. Mm-hmm. The last thing I'll mention here is all of these collections are dynamic. So before I was showing you that, let's just view policies here, that Active Directory server here defined by AD01 and AD02, as new AD servers come online, they automatically are added to the AD server's hosts. And by virtue of that, any software that's defined in AD server services will automatically be pulled in. So to highlight that point, if I come into AD services, which I created right here, and I look at the definition of that software, it literally says application DNS LSAS SBC host system on hosts in collection AD server hosts. So when we look at AD server hosts, what we're looking at here, again, is a definition that says hosts that are matching AD in their host name and are running the LSAS process in listening. So you have to match a certain set of constraints to be added to this group. And when you are automatically added. So it's dynamic policy that adjusts to your environment and its changes without any administrative intervention. And that was, of course, all driven by the ML system on the back end.
Now, so Peter, sorry, do you need software on all of the host clients and servers to get this level of protection?
That is another great question. So no, the answer is that let's go to clients let's go to services, that's better. If I go to services and I view connections, what you can see here is that I have options for controlling globally unmanaged, as well as if I go to the bottom of the list, local unmanaged. Mm-hmm. So I can say, we'll have to find one that does something like this. Great. So SBC host, there's a service that communicates outbound to these various addresses and ports. There's no reason that I can't actually control access here by saying I'm going to block access from SBC host to whatever is on the other side of 10.10.23.84 port 389, which sounds like an LDAP system. So my point is that I can still control using firewall-based semantics. So I can say confirmed SBC host based on these cryptographic properties is blocked from accessing this remote address and port. So it's hybrid in a number of dimensions. I can verify software on one side of the connection and then control what that software is able to access from an address, port, and protocol perspective. And as you can see right here, that even applies to IPv6 connectivity.
That's awesome.
So for something like that, how much intelligence is built into the platform for knowing what to block, and how much of it is knowing your environment, or how much of it is let's turn this off and see what breaks?
Yeah, that's a great point. So the way organizations typically go is what I was showing you before is I started with services, right? In the policy view, I had services and I said, allow clients to talk to services. The second step I did was to enable the enforcement on the underlying AD server collection. What most organizations do is they actually deploy all of the ML recommendations in the approve mode without enforcing the block, which means they get a nice audit log of all connectivity that's happening between those systems. You can slice and dice it any way you want. If you want to understand everything that's going to the LSAS process on any host, this is now showing you all your target hosts, AD01 and AD02, and any communication that goes to LSAS. And this is doing it without actively blocking any of the connections. So it allows you to simulate policy impact and see at a very low level why things are occurring without having to take any lumps, so to speak. And it even tells you, underlying that, what policy caused that to happen. So if you want to understand why this was blocked, you come down here and it says, well, it was blocked because it said unprotected paths were denied from communicating with Active Directory servers, and we enforced this on the destination side of the connection. So you can see all manner of information about what would happen and why it would happen, which is crucial. Because if you look at this and you say, hey, geez, I would not have wanted that to occur, what you're going to do is click this little target icon, and it brings you right back to the policy view so you can make modifications to the policy.
Nice.
So I have another question, and I'm sitting here trying to sort of answer it in my own head, because I suspect that I'm going beyond the what the tool actually does, but the thought that keeps coming to mind is I'm looking at this as an older person and comparing it to firewall rules and firewall methodologies, if you will. and I keep wondering, what do you do, if anything, to validate users? Do you do anything that touches on authentication? You're trusting the applications, but to try to answer my question earlier to Larry, do you masquerade as a user? Do you steal credentials? So you get in, assuming the identity of another user. Do you touch that at all, or is that
Yeah,
sort
we
of
do.
beyond?
It's
Well,
a great point. There's two concepts of user, really. There's the user that I sent over the wire, and there's the user that was at the keyboard that was running the software that allowed the access to occur. We don't look at packets. So we don't look at what you sent over the wire. We look at who you are, right? That's what's important to us.
So
The
how do
concept
you
of
look at who we are? Or maybe you're about to tell us.
Yeah, exactly. So all of this works through system call hooking. You're probably familiar with that because of anti-malware software, where a kernel module is looking at system calls going into the system. And as a result of doing that, it's determining whether there are malicious patterns and malicious data being passed into those calls. We do something very similar to that. We hook a very small set of system calls related to network communications. And when that occurs, maybe a visual helps here. When that occurs, what we do is we intercept the request and we actually collect all of those cryptographic properties to figure out what is it that's communicating? Who is it? What's the container ID? What are all of this complex set of attributes that we then analyze and verify? One of those is simply looking at the user and the associated groups of that user who executed the software. Simple as that.
Okay.
Lee?
With all the cryptographic verification you're doing, how sensitive is the system to updates and patching and the like?
Man, you guys are on fire. That is, I mean, seriously, these are all the questions I love to answer. So that is the name of the game right there. How do you make it so that you don't have to change policies in the face of environmental change? That could be an auto scaling group that scales up automatically. I don't want to have to go modify the policy. Let's say in the previous example, I added an Active Directory server. Should I have to go modify my Active Directory policies to do that? No, it can be automated. So that is through dynamic collections. To answer your specific question, the technology we use to accomplish this, I need to be careful about what I share because it's a closely guarded secret. But what it is in essence is two factors. Number one, where did this thing come from? What is its provenance? And the second thing is, what is its similarity? And similarity scoring accomplishes what you just mentioned, which is to say, how much is this like the old thing that was there? I upgrade MS SQL. The first thing I do is I verify that the new MS SQL actually came from Microsoft. The next thing I do is I say, is this new thing that's there very, very, very similar from a fingerprinting perspective as the old thing? And we're using a very specialized cryptographic function to be able to do similarity analysis that allows us to automatically apply policies to the new software after the upgrade has occurred.
Well, that would make it a bugger to replace a binary with something that was malware or something like that. Even if
Exactly. Yeah, you can't just like replace the MS SQL query studio with Telnet and run random stuff against your database.
But
because
no, hold on, Peter.
Obviously, Telnet looks very different.
Right, and Peter and Leah, you hit on a really great point. When we talk about having a software inventory, it may not even be an approved update, right? Or maybe an approved update that has something else in it. And here's my scenario that I want to run by you, Peter, to see if, and I believe you account for this, is that I'm running some kind of open source software or software that's incorporating open source components. Some other developer has taken control of an open source component and introduced some kind of malicious functionality. Likely that would be enough of a different behavior that your product, Peter, would identify that and go, wait, something's wrong.
You hit the nail on the head. there are identifiers and behaviors. Behaviors are equally as important. Relationships between these identity properties that have never been exhibited before,
Right.
and are indicative of potentially malicious intent. So you'll always verify the origin of the software. Did it come from Microsoft? Did
Right.
it come from a signed Red Hat package? How similar is it to something else? And then what are the behaviors it exhibits relative to the thing that was previously there? And by the way, the last and perhaps most crucial step is provability of the outcome. I am asking network administrators to make risk-based decisions. You don't have specific low-level application knowledge. You're making risk-based decisions based on communication patterns and trends. So how do I prove to you that what is happening was the correct set of decisions? That's what this view is right here. It's a summary that says, right now, you are 100% protected. I know that because guess what? We know all possible pathways of communication. We probe every communication path in the environment to a listening service. So we discovered 547 network paths that arrived at Active Directory. We determined that 354 of them were necessary and 193 of them were not necessary. And we protected all of them so that now you are 100% protected. So it's provable security driven by risk-based decision-making that is ultimately a machine learning system doing that for you.
So how deep can you go into your algorithm, if you will, on this risk-based decision making, or can you at least cover the highlights? Because that term is thrown around a lot, and very rarely does anybody ever like drill down to what exactly are the details.
Yep. Yeah, exactly. So what it comes down to is there's a couple factors. Let me just go through them. One is behavioral. So are there new relationships between software that have not been expressed previously or during the lifetime that we've been observing? The second thing is, are any of the identities that we've collected known to be malicious or suspicious software based on 52 anti-malware scanners that we run the identity properties through? And then the last thing is really around multi-use software. So we've covered behaviors, suspicious behaviors. We've covered suspicious or known malicious software based on identity. And the last one is saying, can we identify that a piece of software is multi-use software? That's really the crux of it. The best way to articulate multi-use is a piece of software that does not have well-bounded capabilities. SSH is a piece of multi-use software. You can tunnel anything through SSH. Telnet is a piece of multi-use software. PowerShell, without being bounded by a script, is a piece of multi-use software. So multi-use software presents risk in your environment because it can be used for both good and bad. And so you need to take special care and identify what software is known to be or could be multi-use software. And that really fills out the dimensionality of risk. Known bad, bad behaviors, multi-use software.
You know, it's interesting, Peter, as I analyze networks and systems and behavior today, you're articulating things as a security analyst that I'm looking for. And usually that means lots of tools and lots of time and lots of analysis to get to where you're talking about going in an automated fashion.
And I think just to sort of put a final point on this is that automated analysis is one of the many things we're quite good at. And so if I were to say to you, how do I get to this database, whatever database it might be? It's going to be, in this case, we'll say a user's database, and it's going to be Mongo, right? How do I get there? What possible pathways could I take to arrive at that database? We do that analysis in an automated way for you because we understand all communications everywhere between every system. We do a graph analysis. So pay close attention to the pathfinder in the bottom left. I'm going to open it and you're going to see some numbers start flipping up. What this is doing is a graph analysis of your entire environment to identify any multi-step pathway that arrives at that database. So there are 7 pathways that arrive at MonGod on LinUser DB01. And some of them are many steps away. So for instance, if I click this guy over here, what I'm showing you right now is actually the pathway an attacker could take to get from the internet, which is Nginx is the bridge between the internet and the internal. So Nginx to the node service, to this Java service, to the login service, and down to the MonGod database. That is one of the pathways the attacker could take to get to your database. And we enumerate all of them for you. So you can look at this as sort of an offensive map that an attacker might use to figure out, how would I navigate this environment? The difference is you as an analyst, you have it before the attacker.
That's awesome.
Yes, it is.
More questions for Peter.
Yeah. So I'm looking at this, and you've got all that automation and visibility and drill down. I'm wondering what you're envisioning as the support burden for something like that in a company. I mean, is this something? I mean, it almost looks like I could have a small business running successfully because they don't need a dedicated team. But what's your model? Where's your target on that?
Yeah, exactly. So it's a balance of high security and automation. So certainly for a mid-market where they have a small amount of resources committed to this problem space, the automation is of high importance to them. In the enterprise, this level of industry-leading protection, verifying identity, both sides of the connection, ensuring it's only trusted software communicating, I personally, and I know I'm biased, but I personally don't believe you can get this level of protection in any other solution available on the market today. And so the driver for a high security environment like an enterprise is the fundamentals of the protection as opposed to automation alone. So there's 2 very different values. Automation for the mid-sized organization that's trying to do a lot more with a lot less, and a level of high security to protect core assets, data, infrastructure, critical systems that I do not believe you can achieve with any other solution on the market. And lastly, to answer your exact question, which was, how much do I need to invest in this as an operator? The answer is the automation makes it incredibly simple to make very quick risk-based decisions. We've gone into environments, deployed. It's a 2-week bake time to make sure that everybody's happy with the state of the software. We deploy it broadly, and literally in a matter of minutes, you go from no protection to full protection with verifiable results. And that's what makes it so simple to deploy. And because these groupings that the ML system creates are dynamic in nature, they auto scale as the environment changes, there isn't a lot of back and forth. You don't go in there and constantly create new policies because it is dynamic and adaptive in its very nature.
That's awesome. Peter, thank you so much for appearing on Paul Security Weekly. It was wonderful having you. I gained a really good insight into how your product works and loved all the question and answers.
Thanks so much, guys. I really, really enjoyed the questions.
And you can learn more at edgewise.com/Security Weekly. That's right.
Hey, Paul, do
Yes.
we have a few more questions for Peter?
No, we don't. We're ending the segment now. We're 2 minutes over time. Sorry. Maybe in the break as we get the next guest on. So securityweekly.com/edge. Edgewise.com/Security Weekly. That's edgewise.com/Security Weekly. You can go there, see special things for Security Weekly readers, including all of Edgewise's previous segments, which have all been awesome, including this one. Peter, thank you so much.
Awesome. Thanks, guys. Really appreciate it. Take care.
Peter. Thanks, Peter.
We'll take a short break, come back with our next segment, which I believe is the security news. So stay tuned.